And we're live. Cool. So today I want to have a look at the database that Ethereum uses. So I know for a fact that everything in the Go-Ethereum Codebase uses Leveldb. And this is actually like a greater level thing than just Go. I know quite a lot of quite a lot of the clients use this as well. It's that or RocksDB, which is a similar sort of system. You know, there's a key value storage. So it's literally you search for a key, you get a value out of it. As opposed to, say, like a SQL database where you've got a table and you search for a row in a table filtering according to stuff. So yeah, I think the Python one uses it. Wouldn't surprise me if the C one uses it as well. But what's interesting is that they wrap it. So they take instead of just using Leveldb and everything, they go into this package, GitHub, Ethereum, let cd go, full size, clear, tmux, give me yes. So they got this ethdb subdirectory. And it's got quite a few things going on in it. And I don't actually know, because I thought they would have just been calling Leveldb, but apparently not. First of all, why have they got some JavaScript stuff in here? Like, what could that possibly be? Build JS. So this looks like it does nothing. It's an empty struct. And the new level database returns a nil and an error not supported. I'm assuming LDB stands for level database. Path returns nothing. So this is empty. Empty nothingness. I'm assuming database is where everything good is. We'll go into that at some point. This is little too. This interface gets a putter and a deleter, and they pass it a key. So you put a key into the value into the key. So this putter interface and this deleter interface, and database has a putter, a deleter, a function which is get, function which is has, close, and new batch. And what I don't understand is the level database has this sort of stuff. Why do you need to wrap it? Batch is a write-only database that commits changes to its host database when write is called, but it cannot be used concurrently. So they don't do it all at once. So like you're committing the put and delete options, and then you call write, and it'll actually do them. Cool. What does that mean? Does that kind of make sense? Table.go. G. Also quite small. The table structure has a database and a prefix. Don't know what the prefix is. New table just takes in those parameters and puts it into it. Explains nothing. Put. Database.put append. It says database is defined in the other file, I guess. And it's going to have put has get delete close. Cool. So this table is internal too, so they can't use it outside of ethdb. The prefix adds it to all keys. So you put and you take a byte you append to byte prefix the key. Put the key value. So I can see how that makes sense. You make a table and it's got this prefix, and then whenever you call operations on it, it's got the prefix on it, so it doesn't. So you're not just saving it to key, you're saving it to whatever this could be, which might be state. So they make a table which is a prefix of state, and then you save the address, but it's got state before it. Maybe, who knows? Table underscore batch. $50 as well. Table batch, same deal. It's got a prefix and table. And then it's got this extra write. Batch is a batch. So they're wrapping that batch, which is in the interface, wasn't it? Table batch. No, it's in the interface. It had a batch. Interface. And then in table underscore batch, it's got the put delete. What's the interface say again for the other bit? Cool. So literally everything is just going to be in this database file. Before I do that though, I might just check what this memory database is. Memory database. Who knows what they're trying to do at this point? This is a test memory database. Do not use for production. So it doesn't actually get saved to the disk at any point. Lock DB key string. So this has got some actual stuff going on with it by the looks of it. So memory database got a database in a mutex lock. Pass it a database, which is just a map. So that's the difference here is, well, the other one's using like Leveldb probably as the back end. This one's just using a map. And then it can have a cap as well. Boring. Put the key, the value into the key. You're like literally just going into this map object. Has your search unit for it. Get. Cool. So this database gives them the option to use a map that takes a string, I think a string, and returns a byte. So it's exactly the same structure as what Leveldb is. Takes a key, which is a string, returns a byte array. That's what a map does too. This just wraps it so they've got the same calls to use this map structure rather than the actual database. Test memory database. So I imagine if we look at database underscore test, it might have memory. Put get new memory database. Put get. What does put get mean? New memory database. Oh, it tests put get. So that's a function here they're calling. And then they go through test values, which is something. Blank string A1251 and with null bytes in it. So they go through them, put it into the database. If there's an error, it fails. And then they try to get it back out. So that's super nothingness. So it looks like absolutely everything is in this Database.go file. Here we go, 300 lines. Actual to the meat of it. Just had to make sure nothing else was going onto it. As you can see, Leveldb, the framework to use it. So we've got a Leveldb instance here. And Leveldb Golang. Might be that one. Sin DTR Go Leveldb. Here we go. So this is what they use. The database instance is this. So that's first of all probably the key thing they're doing there is putting this LDB database structure, and it wraps this Leveldb instance. And that's what this is. So you go Leveldb open file wherever you've got your database saved. If we go here, do I have Geth in here? No, I don't have anything. I'm just going to try to download it, which would be super fun. Where does Geth store? Database. Probably should be looking for the code for this. .Ethereum, cool. C.Ethereum. Cool, so in here, in Geth, there's this chain data. And this is the actual database stuff itself. So when you have a Go level database, you open file ethdb, and theirs is Ethereum Geth chain data for the actual chain data. There's another one for your key storage stuff, I believe. That might actually not be true. Let me look at that. They've got this. Key store. Nothing. Because you've got your account information, but I think that's actually just a file they've got in this key store folder, and there's a specified way you save private keys and stuff. It's semi-standard, I believe. So anyway, back into Geth, back into chain data. So this is where they store the state and the actual transactions. And this manifest file you can already see is 250 megabytes. And that might have been me just looking at it for 10 seconds when I've run Geth, because I don't actually want to download the chain on this computer right now. So the miniest, smallest instance on a Google Cloud. So that 001 manifest, this 0001 log, is where everything's getting saved. But that's really the level database's sort of problem. When you say level database open file, path to database, you're just passing it this Ethereum Geth chain data, and everything in here is this framework's problem. So you open the file, you get this database instance, and with that database instance, you can call get, put, delete, and you pass your key. It's almost exactly the same as using a map. You pass it a string, and it gives you a byte array, or you give it a byte array, and it just saves it all. Gives you some structures here to go through every item in it, an iterator, and batch writes, which I've never used when I've played with it. But I guess they use it here because it's probably more efficient, which would make sense. So back into Database.go. Clear out of that for a moment. So they've wrapped this. They got some metrics for measuring how much the database is using. They got some locks, so when different threads are writing to it, and they got a logger, and that logger is specific to the database path. That's using Go-Ethereum log, which I think they've just copy and pasted another framework for their log one, to be honest. So when you create a new LDB database, you pass it a file, and it calls Leveldb open file, which is, where'd it go? Come back. Open file. So you pass the file here, and it opens it, and that's how you create. No, so you pass the file here, and then it calls it. So when this level database is created, you're actually passing it where the location of the database is. And then it literally just makes it, saves that to DB. So your level database instance to DB here, they're saving it here. fn equals file. And they got your string here. Cool. So what I want to look at in a little bit is where they call this and where they get this file string from. Because I imagine it's saved in your cd home geth dump config. It might be in the config. Eth hash, eth, give me database stuff. Dashboard, localhost. Data-dir. Maybe it's using that. Who knows? We'll see. I'll have to search. And then they're literally giving you all. It literally, this just wraps the function just that are available under this DB. So if you call, you've got your LDB database. You can call path, which gives you the location of it. Yay. You can call put on it, and it literally just calls this function here, which is db.put key value byte value. The value has to be a byte, key has to be a byte. Array. Yep. Cool. Return the result. This returns an error. This returns an error. They just wrap it. This has not mentioned there, but it's the same deal. Get, delete, new iterator. They're all just new iterator with prefix. Yeah, so all these just take the regular database, and this is what it's all going to be using. Because you're going to call you're going to have this database structure here, LDB database, and then you're going to call .put or .has or .get or .delete or something on it. New iterator with prefix. This new iterator here. So it just calls new iterator. Util bytes prefix. Log metrics. Util. So it's a level database utils. So this obviously has some utils. You can add a prefix. Use bytes prefix. Range. Returns a key that satisfies a given prefix. So it's obviously super boring in that all it does is it takes the prefix and nil. So what's new iterator take then? New iterator takes it's this code here. Foo. So you can add a prefix to stuff. So so they must use prefixes a bit. I don't know where or what they're doing for this point, but it's kind of come up twice now. So, and you close the database. You got your mutex locks, which you're locking the database. Passing some. You're making the quit channel if it doesn't exist. Then you call in db.close. So all you're doing is calling database.close, which you know. Defer database.close. So imagine you're doing the exact same thing, you're deferring database close when you got this object. It's going to be called DB as well. And you can return the database itself, super nothingness, some metrics. Meter sets all these to nil, I guess. And reports them to the metrics subsystem. I haven't looked at the metrics subsystem at all at this point. I imagine it's really important. So they're getting time input output. Disk reads, disk writes. So they're measuring, if you've got a function and it's playing with a database, you want to know how many writes you're doing, you want to be knowing how long it's taking to get all this stuff done, so start and finish. And then you spit out this stat table and it's saying this is how much you've read and written to the database. Haven't seen it used yet, so meter. So you got the externally available function. Call in this internal function below it. Meter collections, compactions. It's empty for I. Making 2 compactions. Create storage for input output stats. 2 floats. Create storage and warning log tracer for write delay. Iterate ad infinitum and collect the state. db.getProperty. What's getProperty mean? Haven't seen that yet. Next. So get property must be in this thing. And here it is. Get property returns the value of the given property name. Level database write delay. Returns cumulative write delay caused by compaction. So this is all database optimization stuff, which I don't think I actually want to go through too much because I think I want to stay higher level right now. Level database batch. It's the same thing. It's got an LDB, but it's also got this batch file. So you got the b.batch.put. So that's in here where it says. If you got a batch, new Leveldb batch, it goes that, saves as B. So B is that, and then it's saved as B, so it's b.batch.put, and then batch writes and stuff. Write value size. So you write it all to the batch with these puts and deletes, and then when you do write, it calls db.write, and you pass the batch file to it with nil. Cool. So it just allows you to save it as a batch rather than doing 1,000 reads and writes individually, blocking where you can. Cool. So let's go back out. So in this interface, you got interface.go, and you've got a database interface. It's got a putter, it's got a delete, it's a deleter. So if you get has close new batch, put and delete, you now have a database interface. And I think this interface is what is saved in a few places. So if I go up a bit and have a look at no, I want to search. Get back into ethdb. So in here they call new database and they pass the file. Node service, node go. Database test, database. filters. Core test. I think it's going to be in this node. Alright, let's have a look at the geth one actually. So if we go up here, command geth, chain command, and it is 378. So here, copy DB. So you have the copy DB command. Geth. Key store. Geth dash dash help, save it into file, copydb. Creates a local chain from target. So if I go geth copy db, does that give me? First argument must be the directory containing the blockchain to download data from. So Ethereum options, it's got a data.dir flag, which is Sean's Ethereum. Sync mode fast. Testnet flag. So data directory. So you have to pass it blockchain. And it will read it into here. Cool. Then it calls this function. Sure, we have an argument. If not, you have to give it the chain directory data. Then make a new full node. Make chain. Now, I haven't looked at any of this make chain stuff. This is actually now where it's probably going to get interesting, because now we're digging into how the chains work and how Geth actually sets up the chain after this database one, I think. So, they create this level database from the first argument, which should be the source data chain. So you're passing a level database, and then it will save it into your data.dir. So it creates a database. compacting. What's compacting a database mean? On the way. Analyze the read-write process of Level database. But writing only happens to log file and memory table, and it relies on the compaction process to move the updates. So he just dumps a heap of code. In conclusion, this is drilling into, so it's a level database concept. And I guess if its name means anything, it just compacts it, so it just makes it smaller. Made a few changes. They make monitoring it. So I think they just, it's talking about levels. So I guess like the first level is like the quickest stuff that's saved closely. Second level is less like they might create a level for everything in this level has some level of I don't want to say compaction, but compression or something. And then they save the most common things at the top with no compression, and they might go down X amount of levels, which they talk about in here. Yeah, they talk about here. And it spits out this level. So each level has a certain amount of tables. The table in Level database. Multiple logical tables. What is a logical table in Level database? One host multiple tables. Then you have to partition your key space. Nah, that's not it. So if we look at this again, all this guy does, reads it into a database, make full node. For running the node to sync into. So they call this make full node. Command geth config. Geth config. Make a config node. Register eth service. Make a config node, you reckon? If global pool dashboard enabled. Whisper enabled. According to context. Auto enabled equals flag. Talking about whisper. Add stats if you need it. And that's it. And what is it? It must return stack. Yeah. So what's make config node mean? Config geth config default config whisper default node config. So do we reckon it's says eth there's shush, there's node, there's dashboard somewhere down here maybe? Dashboard, yes. So that must mean they post 8080 to localhost if the dashboard config is true. Default node config returns a node config. Config equals node default config. Client identifier params with version commit. HTTP modules, blah blah blah. Get the defaults, load the config file. Config file flag dot name. Name config dot name. Context global string of config. If file equals context config. They call load if it's nil, which it is nil in this case. They will config flag. Do I have a strings? Oh yeah. Go up. directory, directory flag, prefix, blah, 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 blah. If not, load config. Function load config. If it does not equal nil, call it into get config. It's back into config. So if you pass into the config string a directory, it will load that config. Else it will just use this defaults. So you got stack, register eth service, and utils. Command geth. Eth service. So where is the utils in this one then? Command utils. Utils flags. Din, 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 din. So if we go up, utils flags. Register eth service. Adds an Ethereum client to the stack. Stack.register. Don't know what that means. Sync mode. Download a light sync. If it has sync mode equals light sync, else stack.register and they pass that function. That's all it does in that. So if it's not light mode, stack.register full node equals eth.new. Here we go. Register node service context. node. So when we call this config, there's node config. So that'll probably be the next thing we look at, is up in here there's a node, LMN. I don't know if I want to drill into it right now, so I'll put register. Config represents a small collection of configuration values to fine-tune the network and stack. Uses data directory. So all these fun things. You got your node configs. But they've got a node. Yeah, I'm not going to dig into that today, because that sounds like what I should be doing next. So, in this case, when they're copying it, yeah, that dug down a bit. When they're copying it, they're making a new node. Global text marshal the context. Download a new. So that's where they download it. They open the Level database using the string passed in the first one. Called new header chain using DB. So you're passing that database and making a new header chain from it, which is interesting. And you're making a new fake peer local. Synchronize with the simulated peer. Time.now. New fake peer using a local. Very cool. HC equals current header. You synchronize the current header hash. HC.current header. What's DL? New downloader. Sync mode into chain DB. So you've made your new chain. You've got a downloader, which is obviously their functions to pull the information off the internet, but they've given it a fake way of doing that by adding to this downloader a new fake peer. So in the downloader you register a fake peer, which is a local one, and all it's got is this database. And then it synchronizes with the headers and stuff that's in this copied database, and then compacting into, so they compact it now, whatever that means. Error equals chain DB compact range. And that looks like a function that's on this LDB. Compare compacts the underlying database for the given key range, particular deleted and overwritten versions. are discarded and the data rearranged to reduce the cost of operations needed access. Only implemented by people who understand. Which I don't, but they obviously do. So I think there's probably to fully understand this, you should get a really good understanding of Level Database, which I might do later on. So they compact it. Util.range. Who knows? Remove database. / make config node. It returns a node, and a get config. Stack in config. Where does stack come from? Node.new. And they pass. So you got a node stack, and you pass it to config. Config is here. Cool. So that's all very good. Let's find another place it's been used, possibly in Node. This new level database thing. See how it goes. We can trace a bit more. Node, return new level database. And we go up, we have a look at Node, and it was in Node. Big one, yep. $585, what do we got? Open database. So we return this database structure. Node.config.resolve path name opens an existing database with a given name. So where does that get called then? Back in the chain command. So we go command, geth, back in chain command, 194. Initialize Genesis block. Here we go. This is interesting. So take the JSON file. That's the path of it. Open the file. Defer closing it. Genesis equals new core.genesis. So there's a structure specifically for Genesis files. If when decoding it, you decode it into Genesis, it fails, it's an invalid file. Stack. You make a full node. initialize both a full and a light database. So you go through chain data and light chain data, and you call stack.openDatabase with this chain data. And chain data is where we've been looking. Chain database, hash error, core setup Genesis block. Into this Genesis with this chain. And you write the Genesis into the database. Fails, it fails. Not, it not. Also very, very cool. Init command. Geth. Init. Dash just help. So it goes into the data directory and writes it there. Cool, cool, cool. Where else do we use it? New Leveldb database. Database test, ethdb database jet, filters, 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 bench test, bench test, bench test, bench test, node. That was what we looked at. Node service. Yeah, DAO test. Chain command. Node service. And then swarm too, so I don't want to look at swarm at all. Might just look at node service quickly and say that's probably what we need to look at. In a bit further, because this node directory, service go, small. Context is a service independent options from the protocol stack. So what's a protocol stack then, do we reckon? So service context. Don't know what a protocol stack is. What are they exactly referencing by that? I guess it's like if you use Ethereum as the protocol. And the peer-to-peer network, and then you've got this database, this level database. Open database. So this is where they call a new level database. Takes a name. Resolve path. Service context, resolve path. A service is an individual protocol that we can register into a node. It's a list of peer-to-peer protocols. If it equals blank, the data dir is blank, call a new memory database. Interesting. Else, call it with resolve path at a name. Which is this function below it. What? If that was relative, and if these were actually persistent storage, it would return an empty string. Context of config. What's the config? Is it config? Which I guess is in here. This is in node, isn't it? File path.isAbs. Path is absolute. Yeah, okay. Resolve path if it's absolute, so it's already got slashes. If not, it'll do this. Join C instance dir. Is old geth resource path. Data dir name. So this config file has a data dir and a name. and a data dir. So whenever these things use they resolve the path of the name. And the name that being passed is chain config or light chain config if it's a light one. And then that appends the data directory, which is from the context, which makes a lot of sense. Cool. I might call it there for today. A lot of interesting stuff with that one today. Slowly starting to make sense. Anyway, thank you all for tuning in.